In this video, we're going to be talking about something called Cramer's rule. Cramer's rule is an alternative method for solving a system of linear equations. This example we're going to look at is solving a system of two equations with two variables. So in order to use Cramer's rule, we're going to be given a system in this form: ax plus by equals s and cx plus dy equals t. So from this, we're going to construct something called the coefficient matrix. So what the coefficient matrix is a matrix that uses the coefficients of our x and y values to help us in finding the solutions to this system. So the first column of our coefficient matrix is just the coefficient of your x terms. So we have a and c here. The second column of your coefficient matrix is the coefficients of your y values, so b and d here. So this matrix is called the coefficient matrix. So how do we use this to help us solve a system of equations? So Cramer's rule states that to find the x coordinates of your system's solution, what you're going to do is take the determinant of the coefficient matrix in the denominator, and then in the numerator, we're going to take the determinant of the coefficient matrix in a slightly modified way. So because we're looking for the x, in place of our coefficients for the x values, we're going to put the constant values, s and t, in its place. So you can see that here we have s and t in place of a and c, which is our x values. And then the y values still stay in place, and we take the determinant of that. And then again, the denominator is just the determinant of the full-on coefficient matrix. To find the y value, again, we have the coefficient matrix in the bottom. We're going to be taking the determinant of that. And in the numerator, we're going to be taking the determinant of the modified coefficient matrix. But this time, we're going to put the constant values in place of our y coefficients. So we're going to replace b and d in the coefficient matrix with s and t. And we're going to be taking those determinants. Now, one thing to note is in order to use Cramer's rule, the determinant of your coefficient matrix cannot equal 0. Otherwise, we'd have to solve it using some other means.